welcome to this lesson. Today we're going to be talking about transformations of quadratic equations, or the A, H, and K of quadratic functions. So we are now on to transformations. And again, we've gone over these letters before, but we're going to go over them again in relation to how they work with quadratics. So here we go. A transformation changes the position of a figure. It slides up, down, left, right. Okay? You're going to hear a lot of words called describe. Okay? Describe the transformation. I'm looking for movement words. So did the graph go up? Did the graph go down? Did the graph go left? Did it get bigger? Did it get smaller? Okay? Whenever you hear describe, you're looking at these. Now, describing what? You're describing how the graph moves from the parent function. As a reminder, the parent function of the quadratic is f of x equals x squared, or y equals x squared. And there's a lot of key features of this one. Okay, so if you don't already have it down, one of the biggest key features that we'll be using today is the parent table. So this is -2, 4. This is -1, 1, 0, 0, 1 and 1, 2 and 4. So as you notice, you kind of have this rebound effect where you have the points that go down, and then you hit this point in the middle that goes back up. This is the vertex, because it's in the absolute middle of your graph. Now, we're going to use this parent function, this table, to describe where the graph moves to, because that's what the transformations are doing. They are all moving from the parent function. And this is why it's called vertex form. Because we are getting so special with AH and Ks, it's actually going to give us a little more information than just the transformations. And it's going to tell us what the vertex is now. That way we don't have to go through all the hassle of finding the axis, plugging it back into the equation. Now, the vertex form is just H and K, which is represented by the middle of our table. So you'll always be able to check that. If you did your transformations right, H and K should be the vertex. Now, as for the other letters and for H and K included, they all have the same rules. So A does vertical stretches and compresses, making the graph or the curve narrower or fatter, and it does vertical flips. H does horizontal shifts left and right, and K does vertical shifts up and down. So, same rules, same letters, different graph. Let's go. All right, so let's go ahead and talk about one of the easier ones, K. K is the easiest one. And the reason why it's the easiest is because it does exactly what it looks like. If K is positive, so if K is 3, the graph is going up 3. If K is negative, then the graph is going down that many. Okay, so whatever K is, that is exactly what the graph is doing. And then because this is a vertical graph, we're going to do something new today. Because this is a vertical change, you're going up and down, that's vertical. The way you're going to do this is you are going to add or subtract K from the Y values of the table. So when we get to the next slide, we're going to graph the parent function and use the table. And then from there, we're going to manipulate the table first. Because sometimes it's a little easier to manipulate the table, and then we're going to transfer those points to the graph. Let's do it. All right, so first off, I'm going to come over here. I'm going to do letter A. So always start with your parent function. And here we go. Now, let's look at the equation. Our equation says that K is equal to 3. Now, when we look at it a little closer, we don't have an H, so H is actually 0. So if we do this right, our vertex should be 0, 3. Let's check. All right, so since k is 3, that means we are going to be adding to just the y coordinates 3. So the whole graph is going to go up 3. Now, because I'm only adding to the y's, my x's stay the same. They don't change at all. And now I add to the y's. So 4 plus 3 is 7, 1 plus 3 is 4, and so on and so forth. Now you'll notice the table does that rebound again, where it goes down to the vertex and then back up. And here's my vertex, 0, 3, which matches, so we're doing good. Now we're going to go to the table, or the graph, and we're going to plot these points. There's my vertex, so you can always, if ever you just kind of forget or you want to check your math, you can always start from your points and just go up 3. So 1, 2, 3, there it is. And that's a good way to graph without the table too. You just count from the parent function. But for right now, we're getting used to the table. And there it is. Okay, every single point has gone up 3. All right, video's going to pause. You guys go ahead and do B. And here's what B looks like. So I use different colors. If you do not have different colors, you can always use a dotted line for the parent function. That way you're not distracted. But hopefully it worked. And again, if ever you are confused as to like what your math is, or you just want to double check the math, go to each individual point on the parent function on the graph and just count those numbers, or count K up or down. All right, let's move on to H. H, we already know this one. H is left and right. It is the second easiest just because it's easy to see. But remember, H is backwards. So if it looks positive, it is negative. So if H in our equation, let's say H is x minus 3, using 3 today, that means that H is equal to positive 3, which means it's going right, 3. And if you have x plus 2, okay, well, the only way you get a plus 2 in there is if you plugged in a negative 2. So that means H is equal to negative 2, which means you went left 2. Okay, so always remember H is backwards. Whatever it looks like, it is the opposite. Now let's graph this. Now, X is a horizontal change, okay, left and right. So that means it's going to be affecting the X coordinates. So the Y coordinates aren't changing the slightest, just the X coordinates. And here we go with our parent function. So first off, I'm going to check the equation, and I see here is H. So H is equal to 2, and K is equal to 0. So our vertex should be 2, 0. I'll double check that. So here are my X values, here are my Y values. All I'm going to do is add 2 to my X values. Again, Y values aren't changing. So when we copy our graph down, the Y values can just come straight down. Nothing happened. I'm going to add 2 to everything else. So this is now going to be a 0, 1, 2, 3, and 4. Check my vertex. It is, in fact, the same as what we thought it was. So we're on the right track. Now I'm going to take these points and plot them on the graph. And there it is. All of my points moved over 2. And you can plot your points, or you can check just by counting. So let's check this one. We got 1, 2. Okay, you guys go ahead and try B out. And that's what it should look like. A brief point of critique on your graphs. As you draw them, please make sure you have curves and not V's. I had to adjust my blue one because it was too V-like. We are graphing curves now, parabolas. Okay, absolute value is the V. Okay, let's keep moving. All right, now we're going to graph both of them at once. So we have H and we have K, which means we're adding stuff to the X and we're adding stuff to the Y's, depending on what we're given. So again, always start with your parent function. And hopefully you're getting pretty good at memorizing this parent table by now. Okay, we go to our equation and we check to see what H and K is. So H is a 3, It looks negative, so it is positive. And k is 2. So that means our vertex should be 3, 2. What this means is I'm going to be adding 3 to my x's and adding 2 to my y's. So I'm going to be going right 3, up 2. Okay? And we want to describe. Describe means words. So if ever you see the word describe, this is what I want. Okay? We went right 3, up 2. And if I can write, it'll be correct. Haha. Okay, now it's correct. All right, so let's apply these changes to the table. And here's my table. So I'm actually going to check my vertex and a few of these points just on the graph. You probably already know how to do it, but just in case. So I'm going to do my vertex first. My vertex is currently where we want it to be. And it's just easier to move the vertex first. So I'm going to go right 1, 2, 3, up 1, 2. There's my new vertex. All the other points are going to do the same. So right 1, 2, 3, up 1, 2, and there it is. And you can always move 1 point. So 1, 2, 3, up 1, 2, 3. My bad, it's only up 2. You can always move 1 point and then reflect it across the axis of symmetry. And that's another way to check and make sure your math was right, because it should match up if you reflect it. And that is our new graph. Notice how the vertex matches? We did everything right. Yay! All right, you guys go ahead and do B. And there's your blue graph. We went left 3, down 1. So as far as your descriptions, if you're asked to describe how the graph transformed, we went left 3, down 1. And you can see that from the points and from the math. All right, last letter, we have A. Now remember, A has 2 jobs. We're going to talk about each job individually, just so you can see how they affect the parabola. But I'm sure you're already fairly comfortable with A. So let's go ahead and get started. Vocab words. A is technically a dilation. Okay, think about how when you're in the dark, your pupils, they dilate, which means they get bigger. Okay? Or if you go into the sunlight, they dilate again and get smaller. So dilations are whenever things get bigger and get smaller. Okay? Whenever it gets bigger, it's a stretch. Whenever it gets smaller, it's a compression. Okay? Other words that I'll use are skinny and fat, because the curve gets really, really narrow, really, really skinny, or really, really wide, really, really fat. Okay? I'll be using all those words pretty much interchangeably. Now here we go again. I'm sure you remember, but let's talk about it one more time. If A is bigger than 1, okay, that means you're going to have a vertical stretch. Okay, it's going to get narrower, skinnier. If A is less than 1 but greater than 0, you're going to have a compression, which means it's getting wider. Okay? Remember, the negative has no job here. You're not looking at A as a negative number or A as a positive number. You're only looking at the actual number. So if you have -2, at this point in our lives, we don't care about the negative. We're just looking at the 2, because the 2 is telling us stretch. The negative has its own job. All right, now when we do dilations, this is a vertical transformation, so we're applying it to the y's again. But how are we applying it? Well, let's look. We have y is equal to a times x squared. A times x squared. So what we're going to do for a is whenever we apply it to the y coordinates, we're going to multiply. So here we go with our parent function. And as we look at this first equation, we have a is equal to 1/2. So we're going to apply to our y coordinates only. So the x coordinates, just copy and paste. Okay, so multiplying to our y coordinates only, we're going to multiply by 1/2, or divide. Divide everything by 2. So 4 divided by 2 is 2. And then we have 1/2, 0, 1/2, and 2. Now watch and see what this does to our graph. So our vertex, notice our vertex stays the same. It didn't move. H and K are 0, so our vertex stays the same. Now, however, as I graph this, notice how we have a much flatter curve. Oops, missed. Okay. We have a much flatter curve. It has widened out. So we would call this, because we need to describe, and we got to describe, so we would call this a vertical compression of 1/2. All right, you guys go ahead and do B. Make sure you do the table, the graph, and your description words. Go for it. And here's our blue graph. Notice how really narrow it got. Okay, we spiked all the way up to 12. Okay, it got really, 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 really narrow, more narrow than our parent function. And your descriptive words for this one are going to be a vertical stretch, because it got stretched out, of 3. So those would be your descriptive words. And that's A. Now, quick note here. And this is actually very, very important. Because A is multiplying, you're always going to apply A first. And this makes sense. I mean, think about PEMDAS. You always multiply your stuff first, so you're always going to multiply A first. So if ever you have, and we'll get to these problems, if ever you have multiple transformations going on, you have A, H, and K, all 3 of them, or even just like A and H, or A and K, you're always going to multiply A first. Get that stretch and compression, and then shift the compression or stretch left and right. All right, now reflections. This is probably the one you're most familiar with. If A is negative, it's going down. If A is positive, it's going up. The max or min. All of that is still A's job. All right, so now let's apply this one, and let's throw in a few more curveballs. Okay, so as you can look at this and see, we got a couple things going on. So, like always, I'm going to do A with you. That way you can practice doing 2 transformations at once. And then you guys are going to do B. And then, of course, when the video plays again, you'll see the answer. So here we go for A. You're probably getting tired of me saying this, but, well, always start with your parent function. Always start with the parent table, and always start with the parent graph. It just makes things easier, and especially if you have a lot of little small points, the counting helps make sure your points are in the right place. Now, let's look at what H and K are. So as I look at my graph, or my equation, I don't see an H, so H is 0. That makes life simple. K is a -3. So my new vertex should be 0, -3. And A is a -2. Okay, so I'm going to have 3 different charts over here. I'm going to apply A first, then K, because A is multiplying. So my x-coordinates, because I don't have an H, my x-coordinates don't change. So multiplying by a -2 first. And as you can see, all of these coordinates just flipped upside down. So I went from a +4 to a -8. Now I am going to subtract 3. And here we are. Notice again that the x-coordinates did not change. It was only the y's. And all of those points just shifted down 3. So this is the table we're going to be transforming. This is the table we're going to be plotting. So upside down, I've already got 0, -3 right there. And here we go. You can also use your reflection rules to just plot one and move the other over to make sure you stay even. And there is our official new table, or graph. Now, I see the word describe, so let's use our description vocab. We don't have an H, so don't worry about explaining H. A goes first, so what we're going to say is we're going to say this was a vertical flip and stretch. A did 2 jobs today. That's not how you spell stretch. There we go, that's better. Of -2, and you went down 3. Those are your descriptions. Okay, so if ever I ask you just to describe the graph, that's what you would write down. Okay, go ahead and do B. I'm going to erase some things so we can have more room, mainly with my descriptive words, and go for it. And here's your blue graph. Now, I ran out of room on my actual graph, so it's not exactly at -4, -15, but we can get close enough. And this is what it looks like. Now, as far as our descriptive words go, we have a lot of things to say because we have all three letters. We have A, H, and K. So we're going to have a vertical, flip, and stretch of -4. Then we're going to go left 2 and then up 1. So those would be your descriptive words. So if you were asked to describe, that would be what you would say. All right. If you have any questions, let me know. Otherwise, this is the end of the video. Good luck to you, and I will see you next time.